Hi friends, in this video I will explain definition of coding and modulo arithmetic 2 operations for 5 marks. So first of all we need to define the coding. So coding, it is a redundancy, it is achieved through various coding scheme. The sender adds a redundant bit through a process that creates a relationship between the redundant bit and actual data bits. So whatever the information we want to send from sender, we are going to add an extra bit by means of several coding schemes. The receiver checks the relationship between two sets of bits to detect or correct the errors. So once upon receiver, it has been received the data, and then by applying the reverse operations of a coding, it is going to extract some data. If it is matches, then only it has been delivered on to the next layer, otherwise it will discard. So this is the schematic representation of a coding, it has been happening. So this is the sender, and then here is the receiver. We will be having the encoder at the sender and decoder at the receiver. So message, it has been present, the user wants to send a data. Through that generator, it is going to generating a message and redundancy, or we can say it as what coding it has been applied to generate the redundant bit. And in addition to the message and then the redundancy, it has been passes on to the unreliable transmission medium. Whether we are going to make use of connection oriented communication or maybe connectionless communications. So it has been received at the receiver. So receiver information it has been received, and then here by means of decoder it will check or maybe reverse operation it has been performed. If the redundancy it has been correct, then it will deliver, otherwise it will discard. So to the receiver. Coding scheme can be divided into the two broad categories: block coding and convolution coding. So next we need to look onto the modular arithmetic operation. In modular arithmetic operation or maybe method, only integer in the range 0 to n minus 1 is used. This is known as modulo n arithmetic. For example, if the modulus is 12, we use only the integer 0 to the 11 inclusive, because from 0 also it has been included, then 11 it will be present, totally we will have 12. Modulo-2 arithmetic. In this arithmetic, the modulus n is 2. We can use only 0 and 2. So 0, 1 and 2 numbers we are going to using. Operation in the arithmetic are very simple. The following shows how we can add or subtract the two bits. So it is just a simple addition or maybe subtraction, right? So we'll use the two bits: 0 plus 0, 0, 0 plus 1, 1, 1 plus 1, 0, 1 plus 0, 1. And then similarly, if you subtracting 0 minus 0, 0, 0 minus 1, 1, and 1 minus 0, 1, 1 minus 1, 0. There is no difference between the what addition of binary bits and then subtraction of binary bits, almost same. Here we will have only integer, positive integers. There is no concept of negative integers. So in this arithmetic we use exclusive OR. It is shortly known as a XOR. The operation for both addition and subtraction, the result of XOR operation, if 0, if the two bits are same. The result is 1 if two bits are different. You can just observe this addition and then subtraction, right? So we will be matches, exactly matches with the, if the two bits are same, 0. If the two bits are different, then it will be 1. So and then for exclusive OR operation, we will use this symbol plus, and then under the circle we will be placing a plus. So 0 XOR 0, 1 plus 1, 1 XOR 1, 0, and then 0 XOR 1, 1, 1 XOR 0, it is 1. So in the simplified operation, how we are going to adding the two patterns: 0 plus 0, 0, 1 plus 0, 1, 1 plus 1, 0, 0 plus 1, 1, 1 plus 1, 0. So this is the result or maybe corresponding table for exclusive OR operation. Thank you.